Here's your help video for quiz 3.13. Alright, so starting off with your need to know info. Let's start up here. Radians is a new type of measure for us. It is just a form of measure. You know, we can measure things in degrees or inches or centimeters or miles, yards. I mean, there's all kinds of different forms of measurements. And radians is just another way to measure things. Alright? It's like degrees in that it'll give you the measure of an angle. And you can convert from degrees to radians by using the conversion factors, which we'll talk about in just a second. But in general, a radian measure is you take the arc length and divide it by the radius. And that'll give you that angle in radians. Okay? If you want to convert from degrees to radians, you multiply by pi over 180. If you want to convert from radians to degrees, you multiply by 180 over pi. And we'll talk a little bit more about how to remember that later on. And then lastly, the arc length of a circle, that formula is on your formula sheet. The only problem is, in order to use the formula from the formula sheet, you always have to convert your theta or your angle to degrees. Theta is usually what we represent as the central angle. And you cannot use radians in this formula. So the OHS is going to teach you a different way, but I'm so bad at remembering formulas and stuff that I'm always going to stick with the formula that's on the formula sheet, and I'm only going to teach you this one formula. If you want to know the other way, please dig deep into the OHS and they'll show you another way to do it. Alright, so let's start our quiz. The first question. What is the measure in radians for a central angle of a circle whose radius is 9 and intercepted arc length is 7.2? Alright, well we're just trying to figure out the measure in radians. So we just need to use our little definition of radians here. To get radians, you take the arc length and you divide it by the radius. So it says our arc length is 7.2 centimeters and our radius is 9. So we're going to take 7.2 and divide it by 9. And we're going to get 0.8 radians. That's the measure of this central angle here is 0.8 radians. And it does say to enter your answer as a decimal, so we would leave it as 0.8. Alright, this one says in a circle with a radius of 3 and an arc is intercepted by a central angle of 2 pi over 3 radians. What is the length of the arc? Alright, since our ultimate goal here is to find the length of the arc, we're going to look at our geometry formula sheet and we're going to pick out the formula for arc length of a circle. Alright. So I'm going to use, and again, the OHS is going to teach you a different way. So if you don't love this method, check out the OHS. It's got another method for you. But I'm going to use the formula from my formula sheet. 2 pi r theta over 360. Okay, so here's the deal. In order to use the formula from the formula sheet, your central angle, theta, always has to be in degrees. And right now, my central angle is in radians. So before I even start plugging into the problem, I need to convert from radians to degrees. And basically, the way I remember it is I want pi to cancel out. So if pi's on top, I need it to be on bottom. So my conversion factor is 180 over pi. Because then the pi's will cancel. And I can multiply. 2 times 180 is 360, and 360 divided by 3 is 120. So 2 pi over 3 radians is the same as 120 degrees. That is what I'm going to use to plug in for theta. So let's go back here and start plugging things in. Well, dismiss that. Okay, so I have 2 pi. For r, I'm going to plug in the radius, which is 3. For theta, I'm going to plug in my degrees. Remember, you can't plug in radians. It has to be in degrees. All over 360. Now notice pi is in each of your answers, so you don't actually want to type it in the calculator. You just want to leave it on your answer. So I'm going to kind of ignore it and put it over there on my answer. So when I type in my calculator, I'm going to do 2 times 3 times 120, and I'm going to divide that by 360. And I get 2. But again, I got to leave pi on my answer because I ignored it to begin with, so it has to be in my answer. So the arc length is 2 pi. All right, so this is the same type problem. In a circle with a radius of 6, it has a central angle of 2 pi over 3 radians. What is the arc length? So again, I'm going to use the arc length of a circle formula from my formula sheet, so I don't have to memorize anything. But I do need to remember that theta has to be in degrees. So before I start it, I need to go ahead and convert my radians to degrees. I have 2 pi over 3 radians. I want that pi to cancel. So my conversion factor is going to be 180 over pi. If you did pi on top, the pi's wouldn't cancel. So that's kind of a way to remember it. Oh, didn't we just use this number? Maybe not. 2 times 180 is, we did just use this one. So that's 120 degrees. I could have saved myself a step and not even done that again. All right, now I'm going to plug in. It says to use 3.14 for pi, so I'm going to substitute that in for pi. For the radius, I have a radius of 6. For theta, I changed it to degrees, and it's 120 degrees, all over 360. So this just becomes calculator problem. 2 times 3.14 times 6 times 120, all divided by 360. And it does say to enter your answer as a decimal. And my decimal is 12.56. So that would be my arc length. All right, in a circle with a radius of 2.8 centimeters, the arc is intersected by a central angle of pi over 5 radians. What is the arc length? Okay, so again, arc length, I'm going to pull it straight from the formula sheet. 2 pi r theta over 360. Remember, theta has to be in degrees, so before I get started, I'm going to convert that to degrees. I'm going to take my pi over 5. I want pi to cancel, so I need to put pi on bottom and 180 on top. Those will cancel, and I'll end up with 180 divided by 5, which is 36 degrees. So that's going to be my theta. This is going to be my radius, and I'm going to use 3.14 for pi. So let's plug it all in. So pi is 3.14, the radius is 2.8, and theta is 36, all over 360. So again, we got a fun little calculator problem here. Just multiply it all out. And divide by 360. So I got 1.7584, but it says round your final answer to the nearest hundredth. 100 has 2 zeros, so I need to go 2 decimal places, which means I look at the one behind it. That 8 is going to make the 5 round up. So this should be 1.76 for the arc length. Centimeters. Should have put the units on there. Didn't. Sorry. Okay, so last one. In a circle with a radius of this, an arc is intercepted by the central angle of 5 pi over 6 radians. What is the arc length? Use 3.14 per pi. Round your final answer to the nearest hundredth. All right. So, like always, I'm going to use the formula from the formula sheet. 2 pi r theta over 360. And I should have explained this at the very beginning, but I'm going to explain it now. When we're looking for arc length, man, I'm going to go back here. Sorry, guys. Should have done this. When we're trying to figure out arc length, we're trying to measure the length of an arc. So where the formula comes from, if you think about 2 pi r, 2 pi r is the circumference of a circle. That's the distance all the way around. That's how you measure all the way around. Well, we don't want to measure all the way around anymore. We just want to measure this piece of it. So to figure out that piece, you take whatever this angle is and you divide it by 360. That's going to give you just that piece of it. So you're taking the circumference, 2 pi r, and you're multiplying it by just the piece that you want, which is how they simplified it to 2 pi r theta over 360. So there you go, a little extra math knowledge for you. Now let's go back and actually solve this. All right, so again, my theta has to be in degrees, so I'm going to start off by converting from radians to degrees. I want my pi to cancel, so it's going to be pi on the bottom, 180 on the top. And then I can multiply 5 times 180 and divide it by 6. So this is going to be the same as 150 degrees. 5 pi over 6 radians is the same thing as 150 degrees. That's what I'm going to plug in for theta. This is what I'm going to plug in for my radius and pi. So let's plug it all in. For pi, I'm going to use 3.14. For the radius, I'm going to use 21 5/8. Let me go ahead and convert that. 5/8 is the same thing as 0.625. So just because I get a little freaked out by fractions, which I shouldn't, I'm going to change that to a decimal. So that's 21.625. And then theta is 150 degrees all over 360. So we just multiply that puppy out. And if I didn't state this very clearly, when I converted that fraction to to a decimal, all I did was take 5 and divide it by 8, in case that step confused you. So when I multiply all of this out, I get 56.58541,667. But it says, let's see, what am I doing? To round your decimal to the nearest hundredth. Remember, 100 has 2 zeros, so I want to go 2 decimal places. And look at the one behind it. That 5 is going to make that 8 go up to a 9. So that is my arc length. Okay, guys, good luck on your quiz.